Welcome to the Deep Dive. We're your shortcut to getting up to speed on complex topics.
And today, we've got quite a collection of sources.
We really do. They all seem to zero in on this one really packed week in early November 2025.
Yeah, it's this fascinating point where you've got celestial mechanics, like bumping right up against ancient history and even modern environmental science.
So our mission for this deep dive is to unpack what's happening. We're talking the biggest full moon of the year, a meteor shower famous for fireballs, some unusually high tides, and a 420-year-old tradition involving bonfires.
It's quite the convergence. So where should we start? The moon seems like the big headliner.
Let's do it. The Beaver Supermoon, November 5th. Peak illumination is 8:11 a.m. Eastern Standard Time. What exactly makes this one the biggest, the closest of 2025?
Okay, so fundamentally, a full moon is when Earth sits directly between the sun and the moon. Simple alignment.
Right.
But this full moon happens at the exact time the moon also reaches perigee.
Perigee meaning its closest point to Earth in its orbit.
Precisely. Its absolute closest approach for the entire year. Astronomers call the whole thing a perigee-syzygy moon.
Perigee-syzygy. Okay. And that distance is 221,726 miles, according to our sources. Closer than any full moon since early 2019.
That's right. It's a significant closeness.
Now, the name Beaver Moon, where does that come from?
That's one of its traditional names, often linked back to Native American or early colonial times in North America.
Makes sense.
November was, the month when beavers were really actively building their winter dams, getting ready for the cold. So the name just kind of marks that seasonal activity.
Okay. Now, the term everyone loves, supermoon. We know it's not strictly scientific, right? Coined by an astrologer back in '79.
Correct. Richard Knoll. Not an astronomical term, but it certainly caught on.
It really did. So how much super is it, really? How much bigger or brighter will it actually look to, someone just looking up?
Well, the numbers sound impressive. It can be up to 14% larger in apparent diameter and about 30% brighter than a micromoon. That's a full moon at its farthest point, apogee.
14% bigger? 30% brighter? That sounds like a lot.
It does sound like a lot, but that 30% brightness increase only translates to a difference of about 0.25 magnitude.
Okay, 0.25 magnitude. For listeners not used to thinking in magnitudes, what does that mean visually? Is it a wow factor?
Honestly, it's subtle. Very subtle. Unless you had a micromoon right next to it for direct comparison, the average person's eye probably wouldn't consciously register that brightness difference. You might feel it's brighter, perhaps, but pinpointing it is tough.
So a lot of the wow comes from something else, like when it's near the horizon.
Exactly. That's the classic moon illusion. When the moon is low, your brain compares it to things on the ground, trees, buildings, and that context makes it seem absolutely enormous.
Right. It's a trick of the mind, mostly.
It really is. Which reminds me of that great quote from Neil deGrasse Tyson you found.
Oh, yeah, basically asking if you called a 16-inch pizza a super pizza just because it was an inch bigger than a 15-inch one. Puts it in perspective.
It does cut through the hype. But while the visual size difference might be a bit overblown, that closeness, the perigee part, that is very real effects down here.
Okay, so that leads us to the tides, king tides.
Yep. The moon's proximity is key here.
Why does the closest moon generate the highest tides? How does that work?
Well, tides are fundamentally about gravity at parter, the pull of the moon, and, to a lesser extent, the sun on Earth's oceans.
Okay.
Now, during any new or full moon, the sun, Earth, and moon are roughly aligned. Their gravitational forces combine, pulling in the same direction.
And that creates bigger tides already.
Right. That alignment gives us spring tides, which confusingly have nothing to do with the season. It just means the tides spring up. They have the largest difference between high and low tide.
Got it. So spring tide is the baseline for big tidal ranges.
Exactly. But now add the fact that the moon is at perigee, its closest point. Its gravitational pull is stronger than average.
So you combine the alignment effect with the proximity effect?
Precisely. A spring tide happening at perigee gives you a perigean spring tide, which people commonly call a king tide. The gravitational pull is maximized.
And what does that look like on the ground? How much higher are we talking?
It can be significant. High tides can be, maybe a foot or even more above a typical spring tide high. And the low tides are correspondingly lower too. The whole range is stretched.
And this window for November 2025 is around November 4th to the 8th.
That's the expected window in many places, yeah. The sources specifically mentioned the San Francisco Bay Area as one place to watch.
So for people living there, what's the actual impact? Just wet feet at the beach?
It's often more than that. It's what's called nuisance flooding. Low-lying coastal areas, like parts of San Francisco's Embarcadero, maybe some parking lots near the water, even sections of highways like 101 in Marin County.
They can get water covering the road.
They often do during king tides. It might require sandbags, clearing storm drains, maybe moving cars to higher ground. It's a known issue.
But it strikes me this isn't just an inconvenience. There's a silver lining here for planning.
Absolutely. King tides are incredibly valuable from a climate adaptation perspective.
How so?
They essentially give us a temporary look into the future. They show us what normal high tides might look like decades from now with ongoing sea level rise.
So it's like a real-world stress test for coastal infrastructure.
Exactly. Planners use these events. They see which roads flood, which seawalls are overtopped, which drainage systems fail today under these temporarily higher waters. It provides critical, real-life data to design better defenses for the future.
Makes sense. A glimpse of the future, courtesy of the moon's close past. Okay, so while we're dealing with water on the ground, there's fire in the sky too, right? A meteor shower?
Yes, but, there's a bit of a clash happening out there. We're talking about the southern Taurid meteor shower.
Taurids. Okay. They're active for quite a while.
They are September 20th to November 20th. They come from the debris trail of Comet Tupac.
And they have a reputation for something special, don't they?
They do. Fireballs. Really bright meteors, sometimes as bright as Venus.
Why fireballs specifically from the Taurids? What's different about their debris?
It's basically heavier stuff. Most meteor showers are caused by tiny dust particles burning up. The Taurids, though, the debris, is described as being pebble-sized.
Ah, bigger chunks.
Right. When those larger bits hit the atmosphere, they burn much more intensely, creating those spectacular fireballs.
And 2025 is special for the Taurids, too. A swarm year.
Yes, that's the term used. It means that this year, Earth is predicted to pass through a particularly dense ribbon of comet-angst debris.
So potentially more fireballs than usual?
That's the expectation. Maybe up to 10 fireballs per hour around the peak, which is November 4th and 5th.
Okay, 10 fireballs an hour sounds pretty good. Wait, November 4th and 5th?
Uh-huh. See the problem.
That's the exact same time as the Beaver Supermoon, the brightest moon of the year.
Precisely. It's kind of astronomically tragic. The peak of the potentially best fireball show coincides perfectly with the worst possible viewing conditions.
So the moonlight is just going to wipe them out.
It'll wash out almost everything except maybe the absolute most brilliant fireballs. That intense moonlight glare just makes it impossible to see fainter objects. A real shame for meteor watchers.
That is frustrating. So if someone wants to catch some meteors in November, the Taurids are probably a bust this year near the peak.
Near the peak, yes. It'll be tough going.
Is there another option later in the month?
There is. The Leonid meteor shower. It's active from November 6th to the 30th.
Leonids. Okay.
And, crucially, its peak around November 17th or 18th happens very close to the new moon.
Ah, so minimal moonlight interference.
Exactly. Dark skies. You might see 10 to 15 meteors per hour under good conditions. That's likely to be a much better show this November.
Good tip. Okay, so we have this incredible celestial light show with the supermoon, potentially dimmed by its own brightness when it comes to the meteors. But November 5th itself, that date resonates for another reason involving fire and light, doesn't it? Something much more earthbound.
It does. We shift from the cosmos directly to human history. A 420-year-old one, in fact. Guy Fawkes Night.
Or Bonfire Night. Remember the 5th of November.
Gunpowder, treason, and plot. Exactly. It commemorates the failure of the gunpowder plot back in 1605.
Right, when this group, including Guy Fawkes, tried to blow up King James I and the Houses of Parliament.
Yeah, Fawkes was caught in the cellars guarding barrels of gunpowder. The plot failed, the king survived, and Londoners apparently lit spontaneous bonfires that very night to celebrate.
And it became official pretty quickly.
Almost immediately. An act of parliament mandated an annual public day of Thanksgiving. For centuries, it was a really major state event.
And it had a pretty sharp political edge back then, right? Strongly anti-Catholic.
Oh, very much so. Burning effigies of the Pope was common, along with Guy Fawkes himself. It was tied up in the religious and political tensions of the time, a way to reinforce loyalty to the Protestant crown.
But that mandatory observance eventually ended?
Yes, the act was repealed in 1859. But the tradition didn't die out. It just evolved. It gradually shifted away from the strong religious and political overtones and became more of a general social celebration, the firework night we tend to think of now.
So still bonfires, still fireworks, still effigies, the guys.
Right. But the effigies now might be unpopular politicians, celebrities, or just generic figures. The focus is much more on the spectacle, the community gathering, the fireworks display.
And that old tradition of kids asking for a penny for the guy.
That's largely faded away, yeah. It's mostly about the big organized displays now. A fascinating evolution from political statement to social spectacle using fire and light.
It really is. And that brings us full circle, in a way. All these events, the supermoon, the Taurids, bonfire night, they all depend on light or seeing light or the absence of light.
Exactly. Which leads us to the final critical theme that emerged from the sources, the challenge of actually seeing these things because of our own light.
Artificial light at night.
Yeah.
Ellen. Or light pollution.
Yes. It's becoming a huge barrier, not just for astronomers, but for everyone who wants to experience the night sky. And it's more than just that hazy glow over cities.
What else does it include?
It includes glare, light trespass, light spilling where it's not wanted, and just general visual clutter from poorly aimed or overly bright lights. It fundamentally degrades the darkness.
And the sources highlighted that this isn't just an aesthetic problem for stargazers. It has real ecological consequences.
Massive ones. Think about it. Globally, something like 60% of invertebrates and 30% of vertebrates are nocturnal. Their entire lives are adapted to the natural cycle of light and dark.
So artificial light messes that up.
Completely. It disrupts their feeding patterns, their navigation during migration, their mating behaviors. It throws off their internal biological clocks, their chronobiology. Even plants are affected, blooming or losing leaves at the wrong times.
Wow. And what about human health? The sources mention links there too.
They did. It's increasingly recognized. Elan is linked to disrupting our own sleep patterns, increasing stress hormones, and research is ongoing, but it's being studied as a potential contributing factor to more serious health issues too, like certain cancers and mood disorders.
That's pretty concerning, especially when you see the statistics on how widespread it is.
It's staggering. Over 99% of people in Europe and North America live under light-polluted skies now. There's almost nowhere truly dark left in those regions.
And it's getting worse. There was data on Europe losing dark spaces.
Yeah, quite specific data. Between 2014 and 2021, just 8 years less, the area in Europe considered truly dark, with very low light emission levels, shrank by 5.2%.
5% in less than a decade. That's fast.
It is. It shows a clear, measurable trend of increasing artificial light encroaching on the remaining dark areas.
So what's being done? Is there any regulation? The sources mentioned a lack of a common EU framework, but some countries taking action.
That's right. There's no single overarching law in the EU, but some countries have stepped up. The Czech Republic passed a law back in 2002, Slovenia in 2007.
What do those laws actually do?
They typically focus on practical measures, often pushed for by the astronomy community. Things like requiring new outdoor lighting fixtures to be fully shielded, so they don't shine light upwards into the sky.
Makes sense. Keep the light pointed down where it's needed.
Exactly. And they also often regulate the intensity and the color temperature of the light, restricting the bluer light, which scatters more easily and has a bigger biological impact. Simple, effective steps.
So there are solutions, but they need wider adoption.
Definitely. These national laws show it's possible to legislate for darker skies.
Okay, so wrapping this all up, we've journeyed through this remarkable week in November 2025. We've got the moon at its absolute closest, yanking on the oceans to create king tides.
While simultaneously blasting the sky with so much light, it threatens to overwhelm a potentially great meteor shower.
And down on Earth, we're marking a 420-year-old historical event with our own displays of fire and light.
It really is a week that holds up a mirror to our relationship with light, both natural and artificial. You have these immense cosmic forces at play, shaping our planet and then our own human history, our traditions, our modern impact through technology, all converging.
The irony is pretty thick, isn't it? Celebrating one of the year's biggest natural light sources, the supermoon, and a historical event marked by fire, even as our own artificial light is making it harder and harder to see the rest of the universe.
It really underscores the challenge. We create light for safety and celebration, but we're losing the darkness and maybe forgetting what wonders it holds.
So here's the final thought for you, our listener, to take away from this deep dive. If the Beaver Supermoon is considered one of the best celestial shows simply because it's the biggest and brightest moon, and we know factually that our light pollution is shrinking truly dark skies by over 5% per decade, what else is out there? What other, perhaps more subtle natural phenomena are we permanently losing the ability to witness simply because our own lights are blotting them out before we even fully appreciate their disappearing? Something to think about next time you look up.